when it asks you if an ordered pair is a solution. One of the ways you can work this problem is to be able to graph both of these equations and look to see where they cross, and to see if they cross at the point 12,6. Now we could do that. Now that takes a lot more time and energy and effort, but it could be done. Okay, you would have to put them both in slope-intercept form. You would then have to identify your slope, identify your y-intercept, and graph the equations, which we could do. Everybody agree with that? We can all do that. That's what we call finding it graphically. Okay, that's a graphic. It's a graphing method. We can also determine if a solution is an ordered pair is a solution algebraically. Yes, sir.
I think I know how.
Please share with the group.
You substitute x for the x point and y for the y point. So
Okay.
y would be 6 and x would be 12.
All right. So this would be x, and this would be y. Agree?
Mm-hmm.
And I would have to see if it works in both equations. So in the first equation, I would do 2 times 12 minus 3 times 6, and that would be, and I want to know, is that equal to 6? Thank you, dear. Okay? And I want to know, is that equal to 6? All right, so 2 times 12 gives me what? 24. Minus 3 times 6, which is 18. And I want to know, does that equal 6? Well, 24 minus 18 is how much? 6. So 6 equals 6. Does that work? Yes. So it works for this one. Well, what else do I have to do?
Do it for the next
I also have to see if it works for the other one. Okay? So I'm going to do, instead of x, I'm going to write what? 12. And I want to know, is that equal to 2 times 6? So 12 is now going to be equal to, what's 2 times 6? 12. Does it work for both of them?
Yes.
Yes. So if it works for both of them, is it a solution?
Yes.
Yes. Okay? Now, again, the other method to do that would have been to have graphed them. And when we graphed them, they would have crossed at the point 12,6. Now, we would not have been able to see that because our graph wasn't large enough for us to be able to see that. Does that make sense? So that's one of the disadvantages to graphing, is that sometimes you might not see it because your graph might not be large enough. Does that make sense? So in this case, I could just simply substitute in and double check to see, is that the solution? Now, what if they work for one but not the other? Then it doesn't work.
Not a solution.
Okay, we can say it's not a solution. There is a solution, it's just not that point. Does that make sense? Whereas this is going to have a solution, and the solution happens to be 12,6. Does that make sense? Okay? All right, so what I would very much like for